Yeah. Hi, I'm Tirion. I work at Techniquest. There's a lot of us from Techniquest over at the front, and every single one of them knows that I refuse to use scripts. So I'm given one every show, I refuse to use them. But this is basically on a project that I did back in university, which is sadly many years ago now. But it's basically, can we make glass on Mars? Because every single thing we take over to Mars is going to be very expensive. So anything we can make over there is going to be great. Because at the end of the day, when people talk about Mars, they usually show these kinds of images with the big glass domes. And these are cool, but you're going to need a lot of glass to make these. One thing is, sadly, there are no good images on Google of glass domes on Mars for some reason, so I think this is AI. I did not generate it. I refuse to use AI in any way. But yeah, I wanted to say I will refuse to use it, but this is the only good image I could find for some reason. But is this a future? It depends on what we can find out about Martian glass. If we can make glass on Mars, then great. Fortunately, the university, they'd already done this project, and they'd worked out they can make glass on Mars. There's only one issue. It is completely black. Turns out, most uses of glass, even maybe you could use this decorationally, but if you want windows, that doesn't work. This is not a picture of Martian glass, but we'll come back to that later. During this study, I specifically focused on two main things. I wasn't just allowed to look at how to make Mars glass clear. I had to look at something else as well, which is why I specifically focused on greenhouses. Because if you've got greenhouses, you've got everything else you need, because you've got oxygen, you've got food production, you've got mental well-being, because people on Mars are going to be very lonely. If they've got somewhere they can go, that'd be great. But also, observation, if you can look out onto the world, that would be nice. But I know that a lot of people want to hear about how to make Martian glass clear. We're going to start with the greenhouses, because that's less exciting, and we'll ramp up from there. Because Mars, as many of you probably know, it's not great. It's cold, it's dusty, and there's no oxygen. Or at least very little amount of oxygen. The dust, basically, you're just going to have to continuously clean things. That's just living on Mars. Oxygen, that's going to take a long time. So mostly, it's the cold that's the issue. Because it's going to be anywhere from about kind of 2 degrees to minus 80 degrees on most days. At maximum, it will get to about 20 degrees Celsius on a very good day on Mars. So most of the time, it's going to be very cold, which is why this is the design that we went for. This is specifically in China. You would not think China is somewhere that's freezing cold, but they have some of the most sophisticated greenhouses for cold places that are seen on Earth. And those only are tested down to minus 16 degrees Celsius in order to still grow things. So those basically had a roof, a lot of bricks, and a small-ish window to let in light and to keep that heat in and basically just bounce it around like its very own greenhouse effect. So to make one of these, you're going to need 3 different things. You're going to need a lot of bricks, you're going to need a heating source to keep it nice and warm, and you're going to need glass. Also, I know my PowerPoint skills are not great. This is not the prettiest that it could be. I am an engineer, not a designer. I am sorry. Bricks and heating, those were not my problem. Those are outside of my purview. But I looked at glass, but I did look a little bit into bricks just out of interest, and I found a very interesting article, which is specifically that out of all of the liquids that you could use to make bricks on Mars, the best liquid to use is human blood. Yeah, so it turns out water isn't super available. One thing that is available is people. So, yeah, there is a link to that if you are very interested in that. Good. I would be surprised if anyone clicked that link. It is rough to read. But anyway, more to what I specifically focused on, which is the glass itself. Now, if I showed you a bunch of numbers by different chemicals, this doesn't mean much, but this is basically what they have found Mars soil to be. So it's a lot of silicon dioxide, which is also known as silica, which is in most glass. You've got, the third one is alumina, which is used in most phone glasses and things, so those are already in a lot of glass. The rest of them are below 10%. So, while doing this project, I looked at all of those, and I had to read books from the 1930s to try and work out what effect these will have. None of them were helpful. But in the end, I just went, look, at the end of the day, it's probably going to be Fe2O3 iron-free oxide. That's probably going to be causing the issue. So, we ended up making 2 different samples of that, which was with half of the amount of iron oxide to see if you needed to get rid of all of it to get any effect, and one with 0. This meant then going to a professional and asking them to melt it, which was heated at 1,600 degrees. One sample did fail because we started at 1,500 degrees, and that is not high enough. So that's why we had to go higher and then do a fancy thing called annealed, which is a fancy glass thing apparently. They told me they had to do it, and I just listened to professionals. Which is exactly why I wasn't allowed to do the cool thing of actually dealing with the molten glass. They said I was not trained to do it. I disagree. But this was very, very hot, and we ended up with 3 different samples. The main 2 were the main results of our study, which we found that one was still completely black, and the other was not. We see that it's very bubbly. We're not sure why that happened 100%. We started running out of time near the end, but 50% clearly was not enough to get rid of, but you still got a little bit of yellow. We think that was titanium that caused that, but still much clearer, would potentially be able to actually be windows. You can actually see through it. Apparently, the university said, because we only got one sample of the one with actually clear light going through, that it was too important for me to take with me, and so they took it away from me, which I'm very upset about. If we'd gone 2, I might have been able to take that, but I did get a version of one of the 50%, which I actually do have in my pocket. I have said that I will be happy for people to come over and see it. I'm not passing it around the room. This is one of the only samples on Earth. At one point, my project leader said I am a world expert on Martian greenhouses, and I will never let that go. That is now my personality trait. That's just who I am. Okay, but we worked out the iron oxide is the issue. Okay, so we need to find a way to remove iron oxide. Fortunately, that's simple. Magnet. There are actually 2 types of iron oxide. There's Fe2O3 and FeO2. One of them is magnetic, the other one is not. I got lucky. Fe2O3 is magnetic, it is rust, so using a magnet you should be able to remove most of it. The university did do a lot of other projects and found that if it was below 0.3% weight by volume, it should be clear, which means you just need to remove most of it. A little bit won't do that much on the grand scheme of things. But basically, yeah, you can make Martian glass. It will cause a lot of other work to be done. You're going to need furnaces that can get to very, very hot. You're going to need a way to make big glass panes, and you also need to worry about the bubbles, because I still don't know how to get rid of those. But basically, yeah, that was my entire project. It was a few years ago now, but I loved doing it. I hope you enjoyed learning about it. And yeah, do you have any questions? Question over there?
If there wasn't a way to get rid of the bubbles, would the bubbles have an effect on the efficiency of the greenhouse?
Yes, it would limit how much, because of the diffraction of light as it's coming through, it would also diffract a lot of the infrared light that you need in order to get those plants to grow. There was a not insignificant amount of work looking into plant science, which when I started doing rocket science, I did not imagine I'd be looking into plants and how they photosynthesize. But yes, it would have a big effect, which is why more research would have to be done about, basically you'd probably have to get it even hotter to make sure that those bubbles get out properly. But as it was too viscous, we think, that it just could not get rid of those bubbles, basically. Yeah?
If you did not get lucky with the type of iron inside, what would happen?
So then you would probably need a more complicated machine to basically try to remove the grain sizes of different chemicals in order to isolate the iron oxide and remove it using more complex machinery. Luckily, magnets are much simpler, but yeah, there are machines that can do it, so you just have to take one of those and slowly feed the dust through before it can then be turned into glass, basically. Right back.
Assuming that the glass would go onto Mars, test like the durability of it?
Because we only got one sample, we weren't able to really test how durable it was. Because of some of the other chemicals in it, some of those are already used to harden glass. I think titanium is used quite a lot in order to harden glass already. So it would probably be stronger than some of the early glass that was used early days of human creation, but it would probably still be quite brittle, so it'd still need to be careful. But yeah, it might be stronger than some glasses, but it's similar to obsidian at some points, so it's also potentially quite brittle. Yeah?
How would you scale it up for production on Mars?
That would basically mean you would basically have to go quite slowly. You would send over, most likely, robots to be able to do this over time, have a furnace to get glass melted and into plates, start building your first greenhouse, and then you've got oxygen production and that kind of, you can show that it works. And then once you've got that, you can start sending people potentially because you've got oxygen being created, and then build it up from there. So it'd be a very slow process. I'm always annoyed as somebody who's had to look into it when I see SpaceX things being like, oh yeah, we'll colonize Mars in 20 years. No, you will not. It will be 1,000 years at best. So, yeah. Right over back.
So we're wondering about the furnace aspect you were talking about, and is there any evidence for like how that would work potentially, or like how we generate enough heat in an environment like that? Is there anything like to suggest how we get around that? Or?
Not as much. We wouldn't get as much from solar panels, so solar panels wouldn't be super helpful. But yeah, it's very much one of those questions that you have to go, okay, assuming this, can it be done? We can work out how furnaces happen, but as far as if I remember, there are some underground heating from Mars as well, but I'm not 100% sure about that. That's just from my memory of about 4 years ago, which is not good. So, yeah, I think there are some stuff, but I didn't look into it that much. It was very much, if we had a furnace on Mars, could we do it? But yeah.
Thank you.
All right. Yeah.
I know there's been problems on Mars with like toxins in the soil, and that's kind of messed up any plants. Unfortunately, due to the Martian style, mixing it and making grow stuff in that. So would it be hydroponics we're looking at, or some other kind of?
In the project, it was very much looking at, in terms of most plant life on Mars, what on Earth, what do they need from light? Is it the infrared that needs to get through? Is it the ultraviolet? Is it just the visual light? We were looking at different things of what the plants need, but yeah, we weren't looking as much into if the plants could survive. That would be more astrobotany, which you might have heard very often in The Martian, which is a good film. It is a good film. I do like it.
It's a shame that since it came out, we discovered all these toxins. So.
Yeah, there's always going to be future issues, but it's still fun. Any other questions? Yeah.
Was there any benefit of using a greenhouse over a non-glass building with just like purple lights like they do on the space station?
A lot of the designs I've seen recently are using plastic instead of glass, so it's very much more of that balance between, if you wanted plastic, a lot of the plastic that they use is not, you can't see through it, but it was very much when we were choosing projects, there was a long list of about 500 different projects, and I was scrolling through them for 3 days and saw making glass on Mars, and I refused to put anything else down on the list because that sounds cool. And so it was very much, I was kind of sidelined into, you have to do the glass because that's the whole project, but a lot of other projects have gone, actually, there's a lot of other materials that are better, so we need to prove glass is actually good if you do this. Yeah. Yeah. Any other questions? No? Well, oh, one more? Yeah.
So if glass is easy to make, but bricks aren't, could this be a resurgence in glass blocks, which is on Mars?
I hope so. There are still some projects, we found more water on Mars recently than they thought there was, so there might actually be some more projects going into, okay, can we make bricks with just water instead of, human blood? But if we can put the infrastructure in place to make glass, and we've seen that it's possible, and that if the glass doesn't need to be incredible quality, then you can have bubbles in it and still be a good building block, then yeah, it could be that glass blocks do make more sense in short term on Mars while building the first structures, which would be great for me. But yeah, thank you very much. If you do want to see the Martian glass, you're more than welcome to come see me at any point. I'll be here for a while. But yeah, hope you enjoyed, and thank you very much.